7.3 says use the graphs to determine the value of x for which f of x minus g of x is equals to 1. So f of x is this one that we are given, g of x is the one that we draw ourselves. Now they're asking for the value for which f of x minus g of x is equals to 1, which means f of x needs to be greater than g of x by 1 whole unit. So basically we're looking for when f is on top of g by 1 whole unit in this entire region over here. So what we do is my graph is not drawn to scale, but if it was, it wouldn't be rising this quickly. As you can see on this part, it rises a bit too much, which gives the illusion that it might be -1 in that point. But on your calculator, if you put it, you'll see that that is not the case. So this is a more realistic representation of that angle. So looking at it, if we take our calculator at each of these points, the only point that we can clearly see on our graph, since they said use the graphs to determine the value of x in this interval for which f minus g is equal to 1. So f at this point is clearly 1, and g at that point is 0. 1 minus 0, that gives us 1. So only when x is equal to, what would that point be? According to the demarcations, that would be minus 30. This is 30, that is 60, like that. They increase with values of 30. So when x is minus 30 degrees, we have the difference between their y values being exactly equal to 1. There might be another point over here, but using our graph, we cannot tell what that is. We could only solve for that using calculations and our calculator. So our answer will be x is equals to minus 30.